Welcome back to the World Model Podcast. In today's episode, we're going to be talking about the most complex prediction problem in human history, the future of our planet's climate. Our current models are magnificent achievements, but they are limited. They are built on differential equations representing vast, homogeneous systems. They struggle with resolution, with incorporating human behavior, and with terrifying nonlinear feedback loops that characterize our real world. Today, we explore how world models offer a fundamentally new paradigm for understanding and potentially saving our global environment. The key limitation of current general circulation models is their scale. They divide the planet into grids that are tens or even hundreds of kilometers wide. Within a single grid cell, you might have a city, a forest, an ocean, all averaged into one number. This is like trying to predict the weather for North America by only looking at a map the size of a postage stamp. You lose the crucial fine-grained dynamics. A climate world model would operate differently. It would be a multi-scale generative model. At its foundation, it would still understand the fundamental physics of fluid dynamics and radiative transfer. But it would also learn from a satellite imagery, ocean buoy data, atmospheric sensors, and even economic and social data streams. Its latent space wouldn't just represent average temperature, it would represent the state of local ecosystems, urban heat islands, soil moisture content, and phytoplankton blooms. This model could then do what current models cannot: run high-resolution ensemble forecasts that account for wildcards. What is the precise impact of a massive reforestation project in the Amazon on regional rainfall patterns? What happens to global shipping routes and their emissions if the Arctic ice melts by 50%? How does a change in agricultural policy in the Midwest affect the nitrogen cycle in the Gulf of Mexico? A world model could simulate these interconnected systems in a way that our current siloed models can only dream of. Perhaps the most powerful application is in modelling tipping points. These are the dreaded irreversible thresholds in the climate system. The collapse of the Greenland ice sheet, the dieback of the Amazon rainforest, the release of Arctic permafrost methane. Current models can guess where these points are, but they are notoriously bad at predicting the exact triggers and the cascading consequences. A world model on a paleoclimate data and modern observations could simulate millions of pathways toward these tipping points. It could identify the early warning signals, the flickering of a system before it collapses, that we should be monitoring with extreme urgency. It would not give us a single doomed forecast. It would give us a probability map of futures, showing us precisely which levers we can pull to steer away from the catastrophe. This is not a distant dream. Research organisations are already building the precursors. The European Centre for Medium Range Weather Forecasts is integrating machine learning models to improve their forecasts. The next step is to make these models generative and causal, transform them from forecasting tools into full-world simulators. My controversial take is that a robust climate world model is more important for our survival than a fusion reactor or a carbon capture plant. Why? Because it provides the one thing we desperately lack: clarity. It can cut through the political noise and the economic uncertainty to show us with terrifying precision the cost of inaction and the efficacy of intervention. It can tell us which green technologies will have the biggest impact, which policies are mere virtue signalling, and where we should concentrate our global resources. It would be the ultimate policy tool, the ultimate guide for investment, and the ultimate warning system. Building a high-fidelity world model of the Earth's climate is the single most important scientific project of our time. It is the project of learning the pulse of our world before it flatlines. But just as we can model the natural world, we can model the system humans have built on top of it, the global economy. Our next episode examines the creation of a digital twin for the entire world's financial and logistical networks. This has been the World Model Podcast. We model the world to save it. Subscribe now.